So hello dear students. So this is in continuation with the last topic which was the chapter 12. I have started. Okay. So everything we have learned about was the organic chemistry, the tetravalency of carbon, catenation, which I have given you as a homework. Okay. And hybridization I have told you, right? So today we will see what are the types of bonds. Okay. So already I have told you bonds are nothing but they are the connection which links two atoms together. Okay, so if I say you that there is carbon and there is, say, hydrogen, so this carbon and hydrogen are two different atoms, right? But when they are linked with a bond, okay, they become a compound, right? They become a molecule. Okay, earlier they were two different atoms, but they, when they bind together, when they are connected together by help of a bond, okay, they are said to be a molecule or compound. Okay, now how this bond is formed, it is because of the electrons. Okay, these electrons, the valence electrons, they are responsible for the formation of such kind of bonds. Okay, so today we will see what are the different types of bonds. Okay, so all these, again I'll tell you, these all are just I'm giving you a overview, not the detailed one. Okay, otherwise this organic chemistry chapter will never end. Okay, it is so vast. Now two types of bonds are there. One is the sigma bond, another one is the pi bond. Okay, so sigma bond is nothing but it is the bond which is formed by the head on overlap, or you can say direct overlap, head. Okay, overlap means um overlap means what I can say, it overlap means meeting. Okay, meet, overlap of atomic orbitals. Again I have already said you what is orbital. Okay, where the electron resides. Okay, so now see, I have already said, once the in the last lecture, that s orbitals they have different shape and p orbitals they have different shape. So this circle, it is the s orbital. Okay, so the s orbital has fair shaped and these dumbbell shape type, right? So this is the p orbital. Okay, so this type, these kind of things, so this is the p orbital, this is the s orbitals. Okay, so you can see this is one s orbital and another s orbital. So when they are meeting directly head, okay, so there is a overlap. You can say I have given the shaded region. So this shaded region is what, where there is the maximum electron density, and this is a kind of bond. Okay, so this bond is formed by the overlap of two different orbitals. Similarly, these p orbitals, when they directly hit each other, that means they meet, they overlap with each other directly, head on. Okay, head. So this is the head part, right? So directly head to head connection when you will get, so there will be a kind of, what to say, electron density present here. Okay, so you have the shaded region is the bond. Okay, and how this bond is formed, because the electron is residing mainly here only, right? So this is the bond. So this is what type of bond, this is all sigma bonds. Okay, and remember, since the head on overlap takes place, the sigma bonds are very very strong. It does not get destroyed very easily. Okay, now the pi bonds. So the pi bonds, how they are formed, they are formed by the lateral overlap, not the head on overlap. Lateral means what, sidewise the orbitals has to meet, not directly. As in sigma bond the head on overlap takes place, but in pi bonds only the sidewise overlap takes place, and that's why they are not very strong, because they are not these, because when these orbitals they meet sidewise, what happens, the bonding is not very strong. I mean the what to say, because the area, they do not get much area to overlap, right? As in head on overlap, it gets like directly they can meet each other, they can overlap with each other, and hence the electron density is more and hence the bond is strong. But when they meet sidewise, they will not get much area, okay, to meet each other or to overlap, and that's why the overlap is weak. Okay, overlap is weak, and hence the bonds are weak than the sigma bonds. Okay, so in pi bonds you can see this is one orbital and this is another orbital, so they are meeting sidewise. Okay, and these shaded regions, they are the where the electrons are present. Okay, and this is the bond. So these pi bonds, they are formed like this. Okay, and since they are weak bonds, they are quite reactive. Okay, that means reactive means what? When you will apply heat, when you will apply say what to say, other things, like when you will expose to air and everything, they will get, what to say, get destroyed. Like when you see iron, when you kept in this at moisture in open, what happens? This we say no, junk lag jana. So that means why junk क्यों लगता है आयरन में? Because iron is not so stable, it is reactive, it reacts with air. Why it reacts? Because there is some logic, right? The atomic structure or the bonding present in these iron compounds, right, and they are not very strong, they get affected. Okay, because of the atmosphere. So since these pi bonds, they are weak, they are very much reactive. So since we are going to learn this chemistry, you should know one thing, that whatever things I say stable, when I say they are not reactive, and whenever I say that it is not stable, it is very reactive. Whenever I say strong, it is not reactive, but whenever I say weak, it is reactive. Okay, so I think somewhat you are getting whatever I am trying to imply, right? Now slowly we are trying to move to our chapter. Okay, so all these were just introduction, but actually what your chapter wants, we are just starting to enter, right? Now see, remember these points, these 3 points you have to note down. If now till now you have not noted, you start noting now. But okay, so these 3 points are very important for this chapter. Okay, so these are not introduction, it is required. All sigma bonds are all single bonds are sigma bonds. I'll tell you what. See, if I say this molecule is there, this methane molecule is there. Okay, now why it is said methane, that also you will learn in this chapter only. Okay, so when you see this methane, so in methane the carbon connected to hydrogens, they are all single bonds, right? Already I've said you what is single bond. So all the carbon connected to four different hydrogen, the four atoms, the four bonds are the single bonds. So these single bonds, they are always the sigma bonds. Okay, sigma bonds, that means they are formed by the head-on overlap of the atomic orbitals. So whenever I ask you how many sigma bonds are present in methane, you will say four sigma bonds. Why? Because there are four single bonds. So as many number of single bonds, that many number of sigma bonds. Okay, so this is done. Now when we say double bonds, when we say double bonds, so in double bonds, there is one sigma and one pi. Okay, so whenever say double bonds, so when I ask you how many sigma bonds is present in a double bond, so there is one sigma bond and one is the pi bond. Okay, so in double bonds, there is one sigma bond and one pi bond. So here you see I have written, so this is the ethene molecule, right? So this one. So here you can see this carbon is connected to this carbon, only this carbon you just see, it is connected to this carbon, the hydrogen and hydrogen. So you can see there are three single bonds, right? I mean two single bonds are there. So two sigma bonds will be there. Again, in double bond, one sigma is there, so plus one, right? Again this side if you see, this is one sigma and this is one sigma, so how many? Again two. So in total how many sigma bonds are there? Five sigma bonds. And how many pi bonds are there? Since there is one double bond, there will be one pi, so one pi bond, right? So in this compound there are five sigma bonds and one pi bond. See, these exercises are there in your book. Okay, I'll give you to do the question. You just need to understand so that you do the questions. Now we will see one example. We will see of triple bond also. So when I say a triple bond, so in triple bond, in case of triple bond, one is sigma and two is pi. Okay, this is sigma, okay, and two is pi. Okay, so in case of triple bond, the one bond is sigma bond, it is formed by the head-on overlap. The two bonds, other two bonds, they are the pi bonds, they are formed by the lateral overlap. Okay, again I will tell you, you need not go into detail because everything you will learn in chapter 4. Be relieved. Okay, I'm not lying you. Okay, all these you will learn in chapter 4. No need to be panic. Okay, no need to panic. So this compound I have shown you. Okay, so this is what, this is, you see how many sigma and pi bonds you have to calculate. So you see this is one sigma I have marked. Okay, one sigma, that is 2. Now in triple bond you have one sigma again, right? So that means total 3 sigma bond. And how many pi? Because this is a triple bond, there will be 2 pi. So 3 sigma bond and 2 pi bond, right? So done. Like this, whenever a question comes and they ask you calculate or find out the number of sigma bonds and the number of pi bonds, so whenever you remember these 3 points, you can easily do it. That's why I'm telling you that you just write down these 3 points. Okay, because you are new to these all these things, you will forget. It is natural, so you note down so that it will be, you will not forget. Okay, so this point I have marked you, I have given you a right sign that you note down in your copy. So here one question also I have given you, find this sigma and pi bond. So I have calculated also because I think you will get, so I have calculated also, right? So these question you try to uh, check it, what I have told and what I have written, is it correct or not. Okay, so this structure was given to me, this compound was given to me, and this compound first of all I have break like this, right? So structure I have written and then I have calculated the sigma bond and the pi bond. Okay, like this also only you have to do. If you get any confusion, you please ask. Okay, so you can see the single bonds I have marked as sigma bond, and whenever there is a double bond, one is sigma and one is pi, right? And whenever there is a triple bond, one is sigma and two is pi. Like that, sigma, if I calculate, it is 1 2 3 4 5 6 7 8 9 10 11, and not 11, 1 2 3 4 5 6 7 8 9 10. So 10 sigma, and pi, if I see triple bond is there, so 2 pi, double bond means 1 pi, so 2 plus 1 is 3. So there are 3 pi bonds and 10 sigma bonds. Now one more question will comes. Okay, that also I'll complete today itself. So that is, find out the type of hybridization in the carbon atoms, in the given carbon atoms. Okay, so already I've said you, when there is sp3, it will be tetrahedral. And when it will be sp3, when your carbon atom will be connected to 4 different carbon atoms, right? So that will be sp3. sp2 is trigonal planar. Okay, trigonal planar, your carbon atom, when it will be connected to 3 different atoms, it will be, the shape will be trigonal planar. Okay, and that is sp2 hybridization. Okay, whenever sp means linear, whenever your carbon atom will be connected to only 2 atoms, the shape is linear. Okay, so these sp2 and sp3 have, I'll tell you, sp3 means carbon connected to 4 atoms, it is sp3. sp2 means carbon connected to 3 atoms, it is sp2. sp means linear, carbon connected to 2 atoms, it will be linear. Now the last one is the question. Okay, so how you will do the question? So find the nature of hybridization in the carbon atom. So here you see first one, you will see I have, see, first of all the compound is given, but I'll write like this because CH2 means what? C and two hydrogen. Okay, so this hydrogen you can write up also, down also, anywhere. So CH2 double bond C double bond O. So one by one I'll try to find out the hybridization. See, this carbon can have different hybridization, this carbon can have different hybridization. That's why I have marked A and B. You can mark 1 and 2 also. Okay, so I have seen that A number carbon I have written here for your convenience. The carbon marked as A is attached to three atoms. You can see one directly connected, directly, two and three. So this A carbon is connected to three atoms directly, and that's why the hybridization of this carbon marked as A will be sp2. The shape will be trigonal planar. The shape also you have to write. Now this carbon B marked as B is connected to, I'll show you. This carbon marked as B this carbon marked as B is connected to 1, 2 atoms directly. Okay, directly connected. Directly means कार्बन के साथ में जो कनेक्टेड है, ठीक है, उस कार्बन के साथ में कनेक्टेड नहीं देखना है, जिस कार्बन का बात चल रहा है उस कार्बन के साथ में कितना कनेक्टेड है, कितना एटम्स कनेक्टेड है. तो अगर बी नंबर कार्बन जो मैंने मार्क किया है उसके साथ देखोगे तो दो एटम्स कनेक्टेड, एक है ऑक्सीजन, एक है कार्बन नंबर ए, राइट. तो जो बी नंबर कार्बन है उसका हाइब्रिडाइजेशन क्या होगा? sp होगा, जो कि लीनियर शेप होता है. ठीक है, आई थिंक इट इज क्लियर. सो दो एटम्स के साथ तो sp2, और चार एटम्स अगर कनेक्टेड होगा तो sp3 होगा. सो हियर आई हैव नॉट शोन यू sp3 बट आई विल गिव यू क्वेश्चंस. सो इन बेंजीन, अभी ये देख लो बी नंबर, राइट. So here you see in benzene C6H6. Okay, so these points, these corners, they are the carbon atoms in benzene. Okay, and these are the double bonds. Okay, so कार्बन जो है ये कार्बन, ओके, दिस कार्बन से ये कनेक्टेड किसके साथ है? कितना एटम से कार्बन का? यू सी 1, 2, डबल, 3, तीन ही है, लेकिन सिंस कार्बन इज टेट्रावेलेंट और एक होगा जो कि शो नहीं किया है यहाँ पे, तो दैट इज व्हाट? हाइड्रोजन. So likewise you will put hydrogens everywhere will be there, okay, at each carbon atom. Now each carbon atom you see it is connected to this carbon atom. If I am talking about it is connected to 1, 2 and one hydrogen is there, so three atoms. So if I talk about this carbon, say, so it is connected to 1, 2 and 3 atoms. Okay, that means these hybridization of this carbon will be sp2, which is the trigonal planar. Okay, so I think it is clear to you. Okay, I have tried to explain you everything. If you have any confusion, you please ask me. I'll give you questions to do. Thank you.